Good evening, everyone. Today I'm going to be talking to you about my project for the Survey of Predictive Analytical Techniques class and on identifying scanner bots. For this presentation, I'm going to be going over the problem of what we're actually trying to accomplish and the analytical methods used in dissecting that problem to produce a results of my data analysis. And we'll actually get into that and talk about what was the outcome and what we can expect in the future. So first off, the problem definition. Web servers are constantly under attack from cyber criminals, and part of this problem is that there is some software out there that has issues. Open source software is easily identifiable. If there's an exploit and people don't patch and don't keep up to date on it, it can cause a lot of problems. So scanner bots exist out there to find the software that's unpatched and report back any findings, anything it finds on where that website's at and what the issue may be. And we're talking about anything with where it could allow an attacker to get into the server and run an exploit where they could deface the website, take the server down, or add the server to their botnet and allow them to do any number of malicious activities. So we need to have a defense. We need to be able to identify these and then these potential scanner bots and block them before they can find a problem and then report it to someone that could cause harm to our cyber systems. To detect scanner bots, we're using a couple different analytical techniques. We're using decision trees. Decision trees have been trained using the traffic data, and it's working off of a flag that is in the traffic data that identifies a scanner bot specifically versus regular traffic. Now, by training this, we're hoping that we can predict if a potential traffic request is actually a scanner bot so that we can stop them as soon as they start scanning versus regular traffic. Then hypothesis testing was a suspicion that a scanner bot will always have a high number of requests per minute. This high number of requests per minute is a indication that it's done by a machine rather than a user, because a user will only hit the request a page in so many times, or make so many requests per minute. So we use hypothesis testing to kind of determine is there actually a good indication here or is there not. And then finally we use regression testing to see the trend of our scanner bots going up or are they going down. And then we want to see the rates of attacks over time. If there is a upward trend, that could be a sign that the server is being targeted. If there is a downward trend, it could be that our blocking is working in our favor. So here's the results of our data. This is showing our population, our training, and some of our predictions and whether they were correct or not. And then here's our regression analysis, which is giving us a downward trend. However, the data does have some outliers that are skewing things, and we would need to see more data over time to really get a good feel on whether we do have a downward trend or if it's just a fluke. And then here's our decision tree, which was trained and is using to determine whether we have a bot or we do not have a bot. With the larger size that I had to scale back the sample size to get this result because it was too much before. What we can determine is that bots can be predicted, and we can identify them, but we need more data to really be sure. And then we also need to measure the impact. So identifying whether the trend is going down based on what we're doing to the bots or not, and more data will go a long ways to that. I hope you guys enjoyed this, and thank you. Have a good night.